climate cycles, and recent climate change. Scientists have been able to study ancient climates and have started following an important principle that if plants and animals today need certain conditions to live, then that must mean that plants and animals of the past also required the same conditions. Using evidence, scientists can tell what kind of plants and animals once lived in an area. They use information found from fossils, tree rings, and pollen records. Fossils are able to tell scientists what kinds of plants and animals once lived in an area. The thickness of tree rings can actually tell scientists whether a certain year was cool or warm, wet or dry. And then from the pollen record, scientists can identify the types of plants that lived in the area, and from this, they can infer what the climate once was. Over millions of years, warm climate periods have alternated with cold climate periods, which we call ice ages. During each ice age, huge sheets of ice called glaciers covered large parts of Earth's surface. Scientists have discovered that there have been many major ice changes in the past 2 million years, with the most recent ice age ending about 10,500 years ago. When those ice sheets melted, the rising oceans flooded coastal areas and large inland lakes called the Great Lakes were formed. Some scientists think that we are now in a warm area between the ice ages, which is called an interglacial. In addition to its long-term cycles, climate also changes in short-term cycles. Seasonal changes and changes that result from the interaction between the ocean and the atmosphere are some examples of short-term climate change. Changes in the amount of solar energy received at different latitudes during different times of the year give rise to the seasons, and these seasonal changes include regular changes in temperature and the numbers of hours of day and night. Another example of a short-term cycle is El Niño, or Southern Oscillation. This is the combined ocean atmospheric cycle that results in weak trade winds across the Pacific Ocean and occurs every 3 to 8 years. Cycles like these can change the climate for decades at a time by affecting the strength of storms and changing positions in the jet stream. Another climate cycle involving both the atmosphere and the ocean is a monsoon. A monsoon is a wind circulation pattern that changes direction with the seasons. During the summer, warm air over land rises and creates low pressure. Cooler, heavier air sinks over the water, creating high pressure. The winds blow from the water toward the land, bringing heavy rainfall. During winter, the pattern reverses and winds blow from the land toward the water. The world's largest monsoon is found in Asia. One of the world's wettest locations, receiving an average of 10 meters of monsoon-driven rainfall each year, is Cherrapunji, India. Precipitation at that area is even greater during El Niño events. Average temperatures on Earth have been increasing for the past 100 years. Globally, average temperatures were fairly steady from 1880 to 1900, and then from 1900 to 1945, they increased by about 0.5 degrees Celsius. A cooling period followed, which ended in 1975, and since then, the average temperatures have steadily increased. The greatest warming has been in the northern hemisphere. The rise in Earth's average surface temperature during the past 100 years is often referred to as global warming, and scientists have been studying this change and its possible causes, and have concluded that most of the temperature increases are due to human activities. Gases in the atmosphere absorb Earth's outgoing infrared radiation and is referred to as greenhouse gases. Greenhouse gases help keep temperatures on Earth warm enough for living things to survive. But over the last 120 years, levels of carbon dioxide have been increasing, which creates a greater greenhouse effect. So what are some of these sources of increased carbon dioxide? Well, first, carbon dioxide already occurs naturally in the atmosphere, and it's due to sources such as volcanic eruptions, forest fires, and cellular respiration of organisms. However, carbon dioxide also enters the atmosphere when fossil fuels such as coal, oil, and natural gases are burned. Burning fossil fuels releases energy that provides electricity, heats homes and buildings, and powers automobiles. Another major impact of humans is deforestation, which is a large-scale cutting and or burning of forests. Forest land is often cleared for agriculture and development purposes. It affects global climate by increasing carbon dioxide in two ways. First, living trees remove carbon dioxide from the air during photosynthesis. So cutting down those trees, they are no longer able to do this natural process. And then when the trees are cut, these trees are also burned, and by burning them to clear fields, humans are actually adding carbon dioxide to the atmosphere. The burning of fossil fuel releases more than just greenhouse gases. It also releases aerosols, or these are little tiny liquid or solid particles. Aerosols reflect sunlight back into space, and this prevents some of the sun's energy from reaching Earth, potentially cooling the climate over time. Now, changing climate can present many challenges for a society, which include heat waves and droughts. They can cause food and water shortages, excessive rainfall, and can even cause flooding and mudslides. Governments throughout the world are responding to problems that are created by climate change and are hoping by educating young people like you that we can eventually stop and reverse global warming. We have reached the end of this section. It is now time for you to show what you know.